in lesson 3, we're going to talk about how to graph lines. Now, this is something we did a lot for the last couple months before March break. So you should be very familiar with it, but we're going to review it one final time. Now, there are two popular methods of graphing lines. The first one we've already learned, which is we make a table of values. You choose the x-coordinates, which are our inputs. We input them into the equation. We find out what the y value is, and then we graph that point. After that, I'm going to show you the second method. Okay, so let's start by looking at this first line here. Let me just move this up a bit so we can see exactly where we're at. Oops. There we go. Okay, and we are going to graph the line y equals 2x minus 7. So let me go over here and do a little rough work. Y equals 2x minus 7. I recommend you to do some rough work. So this is the definitely going to work. It's a little bit longer, but it always works method. So you choose x values. Now I'm going to pick 0 as my first one because that's the easiest, right? Y equals 2 times 0 minus 7. Sub it into x, see what we get. Well, 2 times 0 is 0. 0 minus 7 is negative 7. And there we go. So there's the y coordinate. And let's plot that on our graph. X is 0, y is negative 7. Let's put a point right down there. All right, let's try another one. Now, instead of going 1, 2, 3, 4, I could do that, but it's a little bit quicker. Or not quicker, more accurate if we try to spread the points out. So let's do something. Let's try. Let's do 8. All right. Y equals 2 times 8 minus 7. So 2 times 8 is 16. 16 minus 7 is 9. All right. So that one will fit on my graph. 8 over 9 up. Now look how far apart those points are. That's really good. You don't want to bunch all your points together if you want to get a really accurate line. Let's try one more. Let's try a negative value. Basically, we want at least 2 is minimum, but 3 is required to make sure we do it accurately and do it properly. So let's sub a negative number in. Let's try something like, let's just do negative 1. Because I think if we do negative 2, it's going to go off the graph. So let's do negative 1. All right, 2 times negative 1 minus 7. Well, 2 times negative 1 is negative 2, and negative 2 minus 7 is negative 9. All right, so negative 1, negative 9. Now that one is kind of bunched together with that one. Maybe it would have been a better idea to get something in between, but I really wanted to show you do a negative number. But let's do one more actually. We'll pick a number in between. Let's go with 4. All right, y equals 2 times 4 minus 7. So that gives me 8, and 8 minus 7 is 1. All right, 4 over 1 up. Perfect. All right, let's draw a line through that. I'll get my line tool, and here we go. All right, now when you draw your lines on the graph, there we go. Make sure you label at the end with the equation line, because here it's only one line on a graph, but when you do your homework, you're going to have multiple lines on a graph. So I need you to label at one of the ends. And if you like to use different colors for the lines, that's great. That helps a ton. But make sure you still label at the end with the equation, okay? Not A, B, C, things like that, with the actual equation. All right, so there's the one method of doing it. Now, I'm going to erase this, and we're going to talk about a different method of drawing the exact same line. So, okay, I've erased it, and let's continue. And now we're going to look at a different method without the table. This method is called using the slope and the y-intercept, or slope-y-intercept form. Let me just move it back up. We'll look at the instructions at the top here. Graphing method 2. Start by plotting the y-intercept. This is the b in the equation. So let's look at our equation, and let's identify what b is. So if we write, I'm going to write below here, y equals mx plus b. That means the negative 7 must be our b. There you go. So b is equal to negative 7. That is our y-intercept, if you remember from our previous lesson and from our previous units. Okay. Now, where is that on the graph? Well, it's always the coordinate 0b. So in this case, it's going to be 0, negative 7. So 0 over 7 down. Now that was already in our table, if you notice. That's when we subbed in 0. So in other words, we can always just look at the equation really quickly, look at where b is, and go on our y-axis and plot that point. Boom, right there. You can do it very quickly. All right, now let's move up and look at the instructions one more time. How do we find more points without making a table? Now this is way faster than making a table, but if you don't like it, you can stick to making a table. It's up to you which method you prefer. But I like the second method better. Once you get good at it, you can graph lines really fast. So we're going to use the slope to move from the y-intercept using rise and run to determine more coordinates. Now what the heck does that mean? Well, let me show you. What's our slope? Our slope right here is 2. So that's our slope. Let me write that over here. The slope is 2. I guess I should have wrote it down here. That's where I meant to write all the work, but I got extra space at the side, so I'm going to do that. Okay? So m is 2. Now, remember, it's supposed to be rise over run. So if I write this as rise over run, there's an invisible 1 on the bottom. So it's a rise of 2 and a run of 1, because that's what slope is. Now, this is a positive slope, so we're going to go up as we go over to the right. If it was negative, I'd go down, but it's positive, so we're going to go up. So starting at that point, our y-intercept, because that's the only point we know so far, go up 2 and over 1, put a point. Now I'm going to draw these little stairs in, but you don't really want them on your final graph, okay? So these, we want to get rid of them when we're done. Up 2 over 1, up 2 over 1. Look at all the points I can find really quickly. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I can do that all day. I can even go backwards. Like if I go backwards, backwards 1, down 2, backwards 1, down 2, backwards 1, down 2. I can keep doing that, doing that, doing that all the way back to here and go backwards 1, down 2 again, find even more points. So that shows some of the points from our table, right? If we look, some of those points are actually already on the graph and in our table. All right, so we don't want all the stairs like I said, so we want to kind of erase those out of our final answer. Oops, better just leave them in for now. All right, so I'm drawing them to kind of show you where the points are, but when you actually draw your graph, you don't want those on there. All right, and then we draw our line through it, and don't forget to include arrows on the end. Okay. There we go. Well, not the best. There we go. You hopefully can be a little more accurate when you're doing it yourself. Include arrows on the end of your line and label it. All right, so get rid of those steps that we drew in. If you draw them on your graph, erase them, or just don't actually draw them in, just kind of, hover above with your pencil. So again, this one has a y-intercept, like I said, b of -7 and a slope of 2. And that's how we can do that. All right, let's look at another one. Okay, so here's our second graph. Now, this is where the second method makes life so much easier. When there's a fraction, it's tough to make a table. I shouldn't say tough, but it's just more difficult, right? And a lot of you are going to struggle with it. But let's do it first with the table, and then we can show how much faster it is to use doing the second method. So again, we're going to pick the inputs, and I always start, and you should always start with 0, right? So let's substitute 0 into this equation. All right, now this is pretty easy because -2/3 times 0 is 0, and 0 plus 5 is 5. So that first one was easy. 0 over 5 up. Now here's the problem. If I sub in a number like 1, well, it's not going to be a very nice number because I'm going to go, well, -2/3 times 1, that's going to give me a decimal. It's going to give me -0.66666 plus 5, right? We're going to get this not so nice number, right? We're going to get 4.3 repeating, right? And that's kind of a hard one to graph. So let's not do that. So let me just erase that. So we don't want to sub in a number like 1. Remember, if you remember from our previous unit, we've already done this before. We want to pick numbers, choose numbers that are divisible by the denominator. So we want to pick numbers that are divisible by 3. So a number like 3 or 6 or 9, right? Or -3 or -6 or -9. So watch what happens when we do that. If we sub in 3 instead of 1 or 2, when we divide, the 3's cancel. 3 divided by 3 is 1, right? 1 and 1. So they cancel out, and we just have -2 plus 5, which is, in this case, also 3. So 3, 3, right there. Let's do 6. What happens when we do 6? -2/3 times 6 plus 5. All right, well, 6 divided by 3 is 2, right? And then -2 times 2 is -4, and then -4 plus 5 is 1. So if we choose numbers that are divisible by the denominator, we won't get fractions or decimals, right? It'll eliminate the fraction. So, and we can keep going, and some of you might look at the table, look at the pattern here, right? We're going 5 to 3, I'm going down 2, 3 to 1, I'm going down 2. So obviously the next number, if I go down 2, is going to be -1, and so on and so forth. All right, so that's a method to do this. So it's not that bad. If you pick nice numbers, it works out nice. If you choose inputs that are divisible by the denominator. So let me just graph my last one here, and 9, -1. All right, so there's 4 points. Now, I could have also found a negative point, which would have been a good idea, because look, all this space over here. What if I don't draw it very accurately? So maybe I want to find something else like a -6 or a -3 to draw more accurately. Okay, so and then don't forget to draw your equation, -2/3, x plus 5. Label at one of the ends and make sure you have arrows, okay? All right, this is, again, not the most accurate because, look, I'm kind of not going through my point there. So when you guys do it, make sure you use your ruler and be really careful. It's a little more tough on this program. All right, so I'm going to erase this, and we're going to look at the fast way of doing this. Okay, so I've got it erased, and we are going to talk about the quick way of doing this. Now, the quick way, again, is start at your y-intercept. So what is my y-intercept? That is where the line crosses the y-axis, and it's always this number here, the b in our equation, right? So b equals 5. I'm just going to write that down here in our note also, right? So that means it crosses through 0, 5, 0 over 5 up. So we just start there really quickly. Then, so I'm not doing any subbing in or anything like that. Then we use the slope. So slope, right? Well, slope is the other number, the one attached to the x. That's the m, right? So m. So m equals negative 2 over 3. So let me come over here and let's think about the rise and the run, because when we're working with slope on a graph, we always use rise and run. Now this is a negative rise, so we actually are going down, but we're always heading to the right. So start at the y-intercept and use the slope like a set of directions to move. Go down 2 and then go to the right 3. Put a point. Go down 2, go to the right 3. Put another point. And you can keep doing it. And we're basically getting the exact same points we found before, but it's a lot quicker. Now we can also reverse the stairs. Go backwards 3 up 2, backwards 3 up 2, backwards 3 up 2, and I'm going to keep that going now. Backwards 3 up 2. Look, I can find even more points really fast without having to do substitution or anything else. Now this is not cheating. This is the most effective and quick way of doing it. If you learn this way, you can graph lines really quickly. Draw your line, make sure it goes all the way through the graph and extends past the grid, and don't forget to label it. So if you want my advice, I would practice this second method. Now if you want to make a table to double check your work and be sure you're doing it right, that's great. But if you can master this method, you're going to be a lot quicker. All right, we're going to look at 2 more examples, the 2 weirdos, the horizontal and vertical line next. Okay, we have y equals 7 as the equation. Now notice there's no x. If there's no x and only a y, there's only a y in the equation and no x. We learned this the other day, and we've seen these before. We've graphed these before. This isn't new news. This means, therefore, this is always going to be a horizontal line. Now, you don't need to make a table. You don't need to get fancy. All you need to do is draw the line. But let's see, what would it look like if we made a table? Well, the y coordinates would always be 7, 7, 7. No matter what you make x. So you want to make x 0, you want to make x 1, you want to make x 10, you want to make x negative 2, you want to make x negative 6 or negative 1,000. Now that won't fit on a graph, but the point is, no matter what, the y is always 7. So what does that look like if we draw it? Well, it's going to pass through 0, 7. So now when I do it, I don't make a table. I just draw there 0, 7, right? And I just draw a horizontal line through there. I just go to my y-axis, and where is it? Where's y7? Right there. The end. Y equals 7. So those are nice. There's not any work to do. It's just you got to watch out, not be tricked by them, not be fooled. We don't use the usual method. We just draw a horizontal line. We're done. So let's just make a couple notes down here. The y-intercept, well, the y-intercept for this is 0, 7. What's the slope of a horizontal line? If you remember from our previous lessons, it's always 0. So m equals 0. All right, next we're going to take a look at vertical lines. So let me just move down the page here. All right, now this is a vertical line. How do I know it's a vertical line? Well, from many years of experience, but if there's only an x, notice how this only has an x, there is no y. So if there's only an x and there is no y, this means it is always forever, this is always going to be a vertical line, okay? Now again, there's a lot of stuff here you want to start focus on memorizing a bit, because this is really important stuff moving into grade 10. Now, if we were to make a table, we don't need one for this. Like I said, you can do these really quickly. You can do them in like 2 seconds. You don't have to do all this extra work for these ones. Just draw the line. But if we made a table, the x coordinates would always be 5. And we've drawn these before, right? We have drawn these quite a bit over the last couple months. So this isn't new. This is review. Now, remember, what is y? Y could be 0. Y could be 2. Y could be 10. Y could be negative 10. Y could be anything. Y could be negative, 1,302. Doesn't matter. When we draw this, though, what the heck's it going to look like? Well, we're going to go on the x-axis to negative 5. This is the fast way of doing it, right? And negative 5 is the x-coordinate, 0. And we're just going to draw a vertical line. And that's it. Let me just adjust it here. And that's it. And then make sure we label it. Well, it's not quite, mine's off a little bit, but you guys can be a little more accurate. All right. So what is the y-intercept for this guy? Kind of a trick question. There isn't one. Where does this thing cross the y-axis? It doesn't. What about the x-intercept? It crosses at negative 5, 0. So the x-intercept is right there, that point I labeled. Okay, where does it cross the x-axis? What's the slope? This is another one you're just going to have to memorize. I'm not going to use the slope formula thing. The slope is undefined. All vertical lines have undefined slope. Okay, so that's it for lesson 3. graphing lines. So this is, again, review of something we've done, but you need to make sure you practice it. When you do your homework, do a neat job. Make sure you label all the equations at the end of the lines. Don't forget your arrows.